In this exercise, we show that the limit of n plus 3 divided by n squared minus 13 is 0. We begin with some scratch work. We have to find that critical value of n such that the terms of the sequence are within epsilon of the limit 0. We need to show that this is less than epsilon. So along the way, we can make this expression larger. And then if this is less than epsilon by the transitive property, our original expression is less than epsilon. To make this larger, we can subtract from the denominator and or add to the numerator. So I'm looking for the next perfect square so that this can be factored. Next perfect square is 16, so I subtract 3. And then I want the numerator to match for cancellation, so I add 1 there. Ending up with n plus 4 divided by n squared minus 16. We factor and cancel the n plus 4's. That leads us to this expression, which we then solve for n with these two steps. Now in this expression, what could be the minimum value of n? Well, 1 over epsilon can't be any less than 0, so the minimum value here is going to be 4, and that'll be important later. So here's the formal proof. We start by declaring epsilon greater than 0. Then, by the Archimedean principle, we know that there exists a natural number that's greater than 1 over epsilon plus 4. Now we're going to do some manipulations to turn this expression into something that can be useful in the final line of the proof. So this transforms into n minus 4, which is greater than 1 over epsilon, and finally 1 over n minus 4 is less than epsilon. Thus, for any n greater than our critical value, this is from the formal definition of convergence. We've got the expression for the sequence minus the limit. Simplify here. And now, as we showed, n has to be at least 4, making the denominator positive. Thus, this expression equals the absolute value. As we showed in the scratch work, this is less than n plus 4 divided by n plus 4 times n minus 4. We cancel to get 1 over n minus 4. And now, since n is greater than capital N, this fraction will be smaller than the one with capital N. And as we showed here, this is less than epsilon. So, the absolute value of the difference between the terms and our limit is less than epsilon, and therefore we have shown that the limit of the sequence is 0.